All right, let's take a look at these extra circuit problems and look at how the answers are. Look at number one, which is a little tricky, and let's take a look at what happens. So this is your cell here, your battery, and the positive side is up on top here. And you can see that the positive side, the electricity flows out of the positive and it goes along this wire. And at this point, it has a choice to make. It can either go through the light bulb B or not. And not means it goes off in this direction. It'll go through D. Okay, so that's what we need to think about. Coming out of the positive, it has a choice to go through B or to go over through D. So that's parallel. If you look down here, here's the positive side. And we're actually going down in this circuit picture. It comes up. And there's other ways you could have drawn this. But here I have my choice. And I'm either going to go over here to D or over here to B. And in the circuit diagram, it looks like if we go through B, we then will go through C. Let's see if that's true. So we're up here. We've made a choice to go through B. If we do, we have no choice to go through C. And now we're trying to get back to the battery. And after going through C, we'll join in with somebody, but then go through A. Who we're joining with is the people who went, the electrons that went through D. So if we have current flowing this direction that goes through D, then it necessarily goes through A, but not C. Don't make the mistake of thinking that if it went through D, it's going to go back through C to work back to where it started. It's going from the positive side and it's trying to get over to the negative side. So the current flows down from the positive, goes through D, and then it'll go through A. If we look here, we're going from the positive, and we're going down through D, and then down through A to get back. So what we have is we have B and C are in series with each other on one of these parallel branches, where D is by itself in the parallel branch. And then everything comes back together again right here, and all of the current goes through A. So there's other ways to draw that, but make sure that's what's happening. That B and C are in series with each other, but in parallel with D, and that then all of the current joins again to go through A. So if we look at this and ask ourselves in the next part which one is the brightest, it's pretty clear that A will thus be the brightest. You can think of that in terms of current. All of the current is going to go through A, so A is going to be the brightest bulb. All of these bulbs are equivalent. And notice we use a resistor symbol here, not a bulb symbol, but either one would be correct. Between D, C, and B, which one's brighter? You can think of it in terms of current. When the current came and divided, more current was going to go through D than was going to go through the BC combination. You can also think of it in terms of voltage, how whatever voltage drop is from here to here, D gets it all, and B and C has to split the voltage drop. Most people like to think in current in this situation. More current's going to go through D, less current's going to go through B and C. Finally, B and C will be tied because any current that goes through B also has to go through C. So B and C are tied for last, A getting the most. The next question asks, what's happening if D gets removed? This is an interesting question. So if D gets removed or short-circuited or broken, D goes dim. So obviously D gets dimmer. Interestingly, all of the current that was going through A, we still have all current going through A again, but don't assume that means A is the same as before. A is going to see a very different amount of current now. Since we removed one of the pathways, this made the resistance change significantly and made the resistance bigger. So A is now going to actually be dimmer because there's less current going through the whole circuit. Okay, and that's because we removed one of the possible pathways here. Since A gets dimmer, we can realize that the voltage across A also got less, and that means that B and C got bigger voltages, and so B and C are going to be slightly brighter than they were before. Here we had more current going through A, so A had a bigger voltage drop. Now less current's going through A, so it has a smaller voltage drop. A is not as bright now. So C and B would have to get brighter because they have a more voltage across them. Another way to say it is that used to be sharing current through D, but now it's not. all the current goes through C and B. So in the new arrangement, A, B, and C are all the same brightness. They're dimmer than A used to be, but they're brighter than B and C used to be. And that's number one. So I hope that helped a little bit. This probably get you rolling, and you can do others without screencasts. I may jump in and do another screencast, see if I have time. Anyway, hope your vacation is going well.